Welcome to today's Explainer. Okay, I want you to just imagine our Earth for a second. Picture it suspended in the dark vastness of space, almost like this rare, magnificent specimen. Now, visualize a glowing grid of light wrapping entirely around its surface. Pretty cool, right? Well, today, we are embarking on a cinematic expedition across this very grid. I'll be your documentary guide, and this Explainer is going to be your ultimate interactive field guide. And, of course, your exam prep for grade 6. We're going to master the secret lines that geographers use to navigate our planet's wild habitats. So, are you ready for the challenge? Let's go.
Here's the roadmap for our expedition. We're going to conquer 4 specific zones today. Zone 1, the global grid system. Zone 2, mastering latitude lines. Zone 3, mastering longitude lines. And finally, Zone 4, mapping real-world events. We've got a lot of ground to cover, so let's not waste any time.
Kicking things off with Zone 1, the global grid system, navigating our planet.
Let's jump right into our first challenge. Question 29. What do we use longitude and latitude lines for on a world map or globe? Now, take a quick mental pause here and really lock in your answer. Got it? All right, here's the answer. We use them as a global grid system to find exact places on the Earth. Think of it kind of like a giant, intricate, invisible net cast over the entire globe. Without this glowing grid, finding a specific city or a tiny island or, a towering mountain peak would be pure guesswork. So, the absolutely crucial point here is that these intersecting lines give us a universal language. They let us pinpoint literally any location on the planet with total precision.
Moving right along to Zone 2, mastering latitude lines, the horizontal rings.
Here is your next challenge. Question 30. What are lines of latitude, which are sometimes called parallel lines, and in which direction do they run? Close your eyes and visualize a globe right now. Which way are these specific lines traveling?
Well, they are imaginary lines running horizontally from east to west, right around the globe. Picture drawing a massive ring right around the waist of the Earth and then stacking more rings directly above and below it. These lines travel perfectly horizontally, just sweeping all the way from the east to the west. You are doing great so far. Now let's pinpoint the main anchor of these horizontal rings. Question 31. What is the most important line of latitude and at what degrees does it lie? Think about it. What's the famous name of that line that cuts the Earth exactly in half?
It is, of course, the equator. It's the single most important line of latitude, located exactly at 0 degrees. Now, what's really interesting here is that if you stood exactly on this central belt, you'd actually be spinning through space at over 1,000 miles per hour. Pretty crazy, right? Every single other line of latitude on Earth is measured based on its distance from the 0-degree starting point, which wraps right around the absolute widest part of our planet.
All right, now for a slightly more complex, 2-part question. Question 32. How are degrees of latitude measured, and what is a unique feature of these lines? So how do we count them, and what makes their physical spacing so remarkably special? Okay, here are the key features you absolutely need to memorize. First, they're measured in degrees north or south from the equator, starting at 0 degrees and stacking all the way up to 90 degrees at the poles. Second, and listen up because this is highly important for your exam, they never cross each other, ever. They always stay the exact same distance apart. It's like perfectly stacked rings on a giant barrel. They just run parallel forever, maintaining absolute perfect distance from one another.
Okay, let's shift gears and head into Zone 3, mastering longitude lines, the vertical slices.
I need you to switch your spatial thinking vertically for this next one. Question 33. What are lines of longitude, which are also known as meridians, and in which direction do they run?
They are imaginary lines that run vertically from the North Pole straight down to the South Pole. So instead of rings around the waist, think of these as sweeping vertical slices. They plunge straight down from the icy extremes of the North Pole, cut all the way across the Earth, and anchor right at the frozen South Pole.
Now, just as latitude had its anchor, longitude definitely has one too. Question 34. What is the most important line of longitude, and what is its alternative name? Essentially, what do we call the central vertical pillar of our global grid?
Okay, let's dive into this. It is the prime meridian, the primary line of longitude seating right at 0 degrees. And for the exam, you'll definitely want to remember its famous alternative name, the Greenwich meridian. This vertical pillar is the main starting point for measuring east and west, effectively splitting our globe right down the middle into the eastern and western hemispheres.
Here is our final challenge for the vertical lines. Question 35. From where to where are degrees of longitude measured? And where do these lines cross? Think carefully about how this differs from what we just learned about latitude.
So unlike latitude, longitude is measured in degrees east or west from the prime meridian, fanning outwards from 0 all the way to 180 degrees. And here is the major difference you got to remember. While latitude lines never cross, longitude lines always cross. They intersect exactly at the North Pole and the South Pole. All those vertical slices literally crash together right at the very top and the very bottom of the Earth.
And this brilliantly illustrates the complete grid system. Let's do a quick recap. On one side, we have latitude, horizontal lines, east to west, parallels that never cross. On the other side, longitude, vertical lines, north to south, meridians that always cross at the poles. By laying these two distinct systems over each other, we successfully build that glowing global grid we visualized at the very start of our expedition.
All right, final stretch. Zone 4. Mapping real-world events, why it matters.
Here is your final question. Question 36. Why is it important to understand latitude and longitude when we watch or read the news? Basically, how do you apply this imaginary grid to what is actually happening on Earth today?
Well, understanding this grid is incredibly practical. When we watch the news, knowing latitude and longitude helps us instantly locate the exact positions of countries or cities on a world map. It's absolutely crucial for tracking where major geographical stories are unfolding in real time. Whether it's pinpointing the exact epicenter of an earthquake, mapping out the spread of devastating floods, or simply finding the host city of the global Olympic Games, coordinates let us zoom in instantly. This grid literally turns a vast, confusing world into an organized, trackable, and perfectly understandable space.
So, we've built the grid, we've mastered the horizontal and vertical lines, and we've learned exactly how they anchor breaking global news. Now, I want to leave you with this final challenge before your exam. Can you use this global grid to find the exact coordinates of your own hometown? Seriously, look it up. Apply your newly mastered geographical skills, map your own backyard, and walk into that grade 6 exam with absolute confidence. Thank you so much for joining me on this explainer. Until next time, keep exploring.